Okay, so this one is for Chapter 4B review, problem 13B, which is solving a quadratic inequality. And the idea is that you're supposed to use a sign chart for this. So again, what I did was, like in another video, I kind of included those 5 steps that we talked about in class for solving inequalities using a sign chart, which means algebraically. It basically means don't just look at the graph. So step one is we're supposed to try to get an inequality that involves 0. And so probably what most people do is bring this 3 over. So if I do that, then we get negative 4x squared minus x plus 3 is less than or equal to 0. Now, one thing that I think is useful is actually to have a positive leading coefficient. So instead of negative 4x squared, I'd like it to be positive 4x squared. So what I could do is either add everything over to the other side, or I could multiply by negative 1 on both sides. But if you remember, when you multiply by negative 1 on both sides, you have to flip that sign anytime you multiply or divide by a negative. So if you do that, then we'll get positive 4x squared plus x minus 3 is greater than or equal to 0. Remember, that's because I want to make the leading coefficient positive. That's why I'm doing this in the first place. Okay. So really, the solution to the thing in the blue box here and this equation, or inequality that I just came up with, they have the same solution. So that's important. So really, if I can solve this guy, then I've solved my overall problem. Okay, so step 1's done. Step 2 is, well, let's treat that like an equation. And instead of just immediately figuring out when it's greater than or equal to 0, we'll figure out, well, when is it 0? So find the zeros. Zeros slash the x-intercepts. Okay, so to do that, we'll treat it like an equation. 4x squared plus x minus 3 equals 0. And we got to factor this guy. So you might be able to factor it just by doing trial and error with the parentheses, but if not, we can use this method. It's got to multiply to 4 times negative 3, so negative 12. It's got to add the 1, the b term. So those two numbers that would work, 4 and negative 3. And then I use that to split the middle term. So this whole thing is going to turn into 4x squared plus, and then instead of x, it's 4x minus 3x. And then I've got the minus 3. And then don't forget that the whole thing equals 0. I noticed on the last test a lot of people just forgot about the fact that it's an equation that you're working with. Okay, so we're up to there. So now we do the factor by grouping thing. So right here, I can take a 4x out of those two guys. So I'm left with x plus 1. And then out of these, I want to also get an x plus 1. So the term you have to take out is a negative 3, which means I'm going to put a minus 3 right here. And then all that still equals 0. Okay, and then if I finish off the factoring, I've got 4x minus 3 times x plus 1 equals 0. And so then if I set each guy equal to 0 by itself, I'm going to get 4x minus 3 equals 0, or x plus 1 equals 0. So I get, let's see, 4x equals 3, so x equals 3/4, or x equals negative 1. So here are my zeros. Okay, that's when this thing right here equals 0, right? So now at this point, let's make a sign chart. So here's my sign chart. I'm making a big one on purpose. I'm going to put negative 1 on it and 3/4 on it. Those are my x values. And when I plug those into any version of the function I'm using, 4x squared plus x minus 3, or if I wanted to use the factored version, that might be a little bit easier to plug stuff into. Well, when I plugged in negative 1, I would get 0, and if I plugged in 3/4, I get 0 for those. So really the question is now, well, where do I get positives and where do I get negatives for this? So let's take a look. Okay, so let's pick some test points. So we're done with steps 1, 2, and 3 at this point. Now we're doing test points to determine when this expression is either positive or negative. So something less than -1, let's test x equals -2. And this one, it's probably easiest to use factored form because you don't have to really evaluate the entire thing. You can just plug it in 4 times -2 minus 3, and then -2 plus 1. And so that ends up being a negative number times a negative number, which is a positive number. So any x that I plug in that's less than -1 into this expression that I highlighted over here, I'm going to get a positive y value, essentially. Okay, so for the middle part, why don't we test, an easy one would be test x equals 0. So if I plug that in, I've got 4 times 0 minus 3 times 0 plus 1. Well, that's going to be a negative number times a positive number, which is a negative. So the middle here, any x value I plug in from -1 to 3/4 is going to yield a negative value for the full expression. Okay, so we got one more to do. So let's do this one here. So for that, let's test, I don't know, x equals 1 is a pretty easy number that's bigger than 3/4. So if I plug in 1, I've got 4 times 1 minus 3 times 4 plus 1. Well, that's going to be a positive times a positive, which equals a positive. So any number, any x value that I plug in that's bigger than 3/4, this whole thing will be positive. Okay, so now we've made our sign chart. So step 5 is, well, figure out the solution. So the solution here, I know that -4x squared minus x is less than or equal to -3 when, and it's really the same answer as this one. So this is true when 4x squared plus x minus 3 is greater than or equal to 0. Well, that's what we made the sign chart for over here. Well, we know when it's 0 and when it's greater than 0. It's greater than 0 right here. It's greater than 0, or it's equal to 0 there. It's equal to 0 here, and it's greater than 0 on this side of the chart too. Oops. So that means that I get the answers that I want when the x values are in this region or in this region. So I would say when the x values are less than -1, that's when I get the positives. When it's equal to -1, I get the 0, which is what I want, because right here I said I want it equal to 0 too. Or this other chunk over here, when x is greater than 3/4, that's when I get positives, or equal to 3/4 is when I get the 0 value. So here's my actual solution right there. If you wrote it in interval notation, you could say or on the intervals. And so the first one, the lowest x you can plug in is -∞ all the way up to -1, and I want to include -1, so I use the bracket. And then I also have from 3/4 inclusive all the way up to infinity. And then the symbol that you want to use for that is U for union. And that's the solution. So that means that if I were to graph this thing, it would be below -3. The y values would be below -3 for these x values right here. Okay, hope that helps a little bit.